Hi, I'm Victoria Johnson. I'm a GIS analyst and cartographer. I support USAID's Food for Peace program as a contractor with McFadden PAE. And if you've been to one of my talks here before, then you already know, then this talk is not about that at all. Outside of this room right now, if you want to chat cartography and food security, please don't hesitate to find me later. But for the next 20 or so minutes, how far is a sandwich? And hi to everyone on the live stream as well. If you have any questions, please feel free to just tweet them at Hurricane Vicky, and I'll get to them right after we finish up here. So, maybe you haven't been to one of my talks before, and maybe you read the description of the talk or are just seeing that title slide and are thinking, what on earth is this person going to talk about? What does that mean? How far is a sandwich? Like from my person right now? We're maybe 100 feet from the lunch table? And that's sort of what I mean, not how far we are from the nearest sandwich, although I am interested in that, but the 100 feet part. Because is it 100 feet? I don't know. That's a guess. I'm here to talk about how we conceptualize scale and distance and how that translates on the map. And also, this is not an academic talk at all. It's just something I think about a lot. So this story, it's an extremely short story, that's the entire thing, by Jorge Luis Borges, is called On the Exactitude of Science, and it describes a society where cartography has advanced so far as to make a map with a perfect one-to-one scale. And this is a theme that the writer Umberto Eco extended to full absurdity in a cheerfully satirical essay on the impossibility of drawing a map to the one-to-one scale, in which the idea is examined logistically as though it were a real proposition. And that one doesn't fit on a slide, so whatever. That it addresses, it fleshes out the eternal question of the ways in which a map is essentially different from the territory. And one of the aspects of mapping that comes up again and again in conversations, like a couple of us were just talking about this at the Tuesday night meetup, actually, is how the choices we make as cartographers when deciding how to translate the territory to the map, these choices speak as much to and about us as they do to what we're mapping. And scale is one of the first decisions that we have to make when we start planning out a new map. What are we trying to show? How much detail is necessary to convey the information we're trying to share? At what level are we going to condense the entirety of the territory down into the map? And Natural Earth, yay Natural Earth, helpfully asks you this right away. But as one of the basic map elements, much like the north arrow, scale is one of the first things typically covered in Cartography 101, because it's pretty important to have a logical, usable scale on most maps. Not all maps, there are always exceptions. But you do need to have a consistent ratio across the board, and you have to make that clear to the user. So just to get it out of the way, a high-quality globe is really the only way to have a map with a constant, super accurate scale, and there is definitely a deep discussion to be had about map projections as well. This is not that talk. I'm just here to talk about some interesting old stuff and how that relates to what we do today. You see, scale as a concept is hard. Relative size in relation to distance is a historically difficult concept for our tiny brains. And the oldest maps didn't really address scale at all, so we're not going to talk about them. Okay, we'll talk about them a little bit. This is the Tabula Peutingeriana, or Peutinger map, and it is not named for the cartographer, who was likely a 13th century monk, whose name is lost to history, but for Conrad Peutinger, the German humanist and antiquarian who published it in 1591, hundreds of years after it was made. It is considered the only Roman map to survive antiquity, and that's not even really what it is. It's believed to be a descendant of a map originally produced around 12 BC from Marcus Agrippa, a general under the Emperor Augustus, though no one is really sure, and there are other theories about the origin. This particular theory is based on the presence of Pompeii and Herculaneum, among other locations that were not known contemporarily to the time that it was thought to be created or published. And also, by descendant, that's just a nice way of saying copy. It's a 13th century parchment copy of a map, and more than likely a copy of a copy of a copy of a map. And this map is, at heart, a road map. Unlike how we think of road maps today, there's not really a scale involved. Like, you would not take this on the road with you. First of all, it's like 20 feet long. And it's more of a network diagram, a schematic. If you think of it more of the way you think of a subway map, which you can see better again, when you think of a subway map, it's, sorry, lost my notes. Everything connects to each other in the right way, but basically every other aspect is distorted. It's just a long, narrow map divided into sections, and the extent stretches from the British Isles all the way across Europe and the Middle East to India. It's not practical. Like, Italy is like folded up against the Adriatic coast above it, with the entire Mediterranean kind of represented by that little blue area. But back to scales. The first geometric grid with a graduated scale displayed on the map is generally credited to Pei Shu, the Ptolemy of China, produced way before all of that, around the year 267 during the Jin dynasty. And I say generally credited because there is some evidence that another cartographer, Zhang Hang, did that first, the grid part, I mean. Pei Shu is believed to be the first person to add the graduated scale in order to improve accuracy when estimating distance between locations. Unfortunately, that map no longer exists today. His writings survive, which means I can just put a bunch of words up on the screen, and hopefully you've been reading it while I've been talking. And this sounds like common sense to us, talking about the near and far, but we're cartographers, and we've been looking at map scales all of our lives. In the year 267, it was pretty groundbreaking stuff. I mean, consider how long it took for the art version of the idea of the near and far to show up. The first painting, considered to be using linear perspective, was done by Filippo Brunelleschi in 1415. This isn't it, but it's another similar piece of his art. But cartographers, we're usually miles ahead of everyone else. Which, of course, how can we tell how many miles we are ahead of everyone else if we don't know what a mile is? A mile is 5,280 feet, but what does that mean? Well, let's explore. The mile as a concept began with the Roman mille passum, or 1,000 paces. It's a reasonable unit of measure if you know what the Romans considered a pace to be, and can visualize that times 1,000. So a pace is not a Roman pace is not a single step, but it's 5 of them. So it's from like here, 1, 2, 3, 4, 5, to here. It's about 5 feet. So 1,000 of those, roughly 5,000 feet. Cool, but that's not the modern mile. A curious thing about the fall of the Roman Empire and the subsequent splintering is that the definition of a mile splintered too. Throughout the Middle Ages, as various entities rose to and fell from power, well, one of the ways a power will establish control, in addition to mapping their realm, which is obviously key, is to establish its own units of measure for that realm. So the splintering, it led to an absurd proliferation of units of measure across Europe and the Middle East. Some of them, like the Arabic mile, had their foundations in science, which is considered the predecessor to the modern nautical mile, as it adjusted the Roman mille passum to fit 1 minute of an arc of latitude. Others, like the Flemish mile, shown here in this detail of a map by Gerhardus Mercator, don't worry, as I said earlier, this is not about projections, we're not going to get into that. They had their foundations in more ephemeral measures. Here, there's it's a little hard to see because it's small and in Flemish, but there's 3 scale bars, and it's a small, medium, and large Flemish mile, because the Flemish mile is based on walking time. And I would be remiss if I didn't show you the full map. This is the Exactissima Flandria Descripto, and one thing I like about maps from this time in this style is that it's just like jammed with detail. Like the sea is never calm. The sea is just going nuts up there. Every corner has a bear holding a helmet. Like, I sometimes think about adding those details to the maps I make at my job, and I genuinely don't know what my boss would do if I submitted a map of like, you know, drought in Somalia with like a bear holding a helmet in the corner. Different times. Okay. The expanding units of measure meant that cartographers, a practical bunch, often included multiple units of measure on their maps. Not just versions of the same measurement, like we just saw, but whatever miles seemed relevant to the territory at hand. So this is a map made in 1863 by the delightful sounding Society for Useful Knowledge, showing in the corner there's the graduated scale bars in English miles, French leagues, and German miles. And you can kind of get a sense of the difference. Here is a 1790 map of Switzerland that has 5 wildly different scale bars, held aloft by a cherub who seems aware of how silly it looks. Just kind of resigned to their fate. The modern mile, as we know it, 5,280 feet, was first standardized as the English mile under Queen Elizabeth I. In the 1500s, Parliament decided that 1 mile should be 8 furlongs, and a furlong is the distance a team of oxen can plow without resting, which is incredibly universal and reproducible. Oxen will just fall over and die after 660 feet of plowing. So 8 of those, that's how we get the 5,280-foot mile. which does not mean that the mile was set. This image is from a 1949 comic book called The Amazing Story of Measurement, put out by the Lufkin Ruler Company. But without leaving the British Isles, you even have the Scots Mile, which is most notable now for appearing in a Robert Burns poem or two. But the Scots Mile had to be formally abolished by the government 3 separate times before finally disappearing from popular consciousness sometime around the 1800s. So you end up seeing the modern mile defined as the English mile on a lot of maps. Here's a close-up of the scale from a Treasure Island map. I cannot resist putting a fiction map in here. There are a lot of examples of English miles on maps, and that's kind of, when you see that, you can think of that as being the standard mile. I chose this one. I really like that long S. Despite knowing that it says English miles, I'm still going to read it as English miles. You might too. Here's the full map. That measure was not standardized internationally, somewhat incredibly to me, until 1959 at the International Yard and Pound Conference. 1959. I have to click on the GIFs, do I? There we go. In 1959, Chevy introduced the El Camino, and Weird Al Yankovic was born. It's not a long time ago. And this is not even to say that the standard miles are the only game out there. I didn't even touch kilometers, because there's myriad other ways to describe distance on a map, by style and by units. So let's look at some less conventional map scales. This is a map of travel time from London, and it's turning the map itself into a scale, not in length of distance, but in length of time. It's an isochronic scale. And it's one of my favorites, just aside from being very beautiful and rich. It makes the scale tangible. Because I'm the sort of person who needs to have a scale I have some experience with to really understand what's being conveyed. Like, even after all of that, I still think of a mile as being 4 times around the track at my middle school. But we all know what a day is instinctively. This map was updated in 2016 by a firm called Rome to Rio, which is just kind of an interesting map, I guess. And here's another way to show time and distance on a map. And this is, I would call this an early example of an interactive map. It was circulated by the Pure Oil Company in 1944. And it kind of treats the global war in the Pacific like a board game, because there's a lot of little flags along the corner over here. There. And you are meant to cut them out and move them around the map as the front in the World War II changed. But that's not scale. So we'll take a look at the bottom right corner, where you are also meant to cut out that scale bar, center it on Tokyo, and you can kind of move it around to show the distance from Tokyo. And in a nice touch of accuracy, you can see the scale actually narrows as you get closer to the poles. And here's Australia and her natural and industrial resources. And this just has a vertical scale bar. It's rather unusual, but it's a nice use of the space. There would have been kind of an open bit there. And just kind of a good demonstration that you don't always have to stick to the usual. Even just a little tweak will kind of keep things fresh. Here's a rather forward-thinking map from the USGS from the 1970s, giving an oblique 3-dimensional view of San Francisco. So let's get closer to that scale. If you're not looking closely, you might miss that the vertical scale is different from the other two. But it's kind of a nice sort of 3-dimensional aspect, and it's kind of a clean way to show scale across dimension, which was immediately reminiscent to me of the here.xyz logo. Scale often becomes a very different element on novelty maps as well, as those artists will take every bit of space available to them to make weird jokes. Here's the hysterical map of the, it's actually just called hysterical map, I'm not calling it hysterical, of the Olympic Peninsula. And the scale is here a bit more playful. It goes half, 2 quarts, 3.2, 5.2. Just, you know, adding little jokes in everywhere. Here's a cool one. I love a map that omits as much as possible. So I think there might be a little bit of like Huffmania here at play. This is an 1822 map showing the straight line distance from Washington, D.C. And the way I see it, the entire map is the scale bar. It's locations and distances and nothing else, or almost nothing else. The Washington meridian is also clearly marked with the time before and after Washington. So if I'm reading this correctly, which you can't because it's real small, I'm sorry. Norfolk is 126 miles south-southeast of Washington, and it is 5 before Washington, time-wise. I don't really know what to do with that part. So a bit earlier, I touched on the choices we make as mappers and what our final products look like. And one of the aspects of NACIS that I really deeply appreciate is the exploration of personal cartographies and how our individual senses of our place in the world shape those choices, which in turn makes every map a reflection of its cartographer. And I'm thinking of like Sarah Bell's set of maps in the map gallery. Go see them, they're awesome, they're like right on the other side of that wall. It's a series of takes on mapping the same area in different styles. I'm thinking of Dylan Moriarty's talk from last year about how he kind of gained a sense of place by connecting the areas in his hometown. And I wish I don't really have a photo from that. I just have, this is the photo that I took during his talk last year. But my photography skills aside, I mean, it's on YouTube. You should really watch it. It's great. My photography skills aside, I always come away from NACIS sort of effervescent with fresh ideas and new approaches to my work. But people have been really coming up with their own non-standard scales forever. A group of MIT frat brothers famously developed the Smoot after the height of one of their pledges, Oliver R. Smoot, and declared the Harvard Bridge between Boston and Cambridge to be 364.4 smoots plus or minus 1 ear. Buffalo Local News Channel 7 made the Jimmy Griffin scale, which measures projected snowfall totals based on how much beer you should buy for them. And this is based on former Mayor Jimmy Griffin, who suggested that residents facing down the blizzard of 1985 to go home, buy a six-pack, and watch a good football game. So some solid advice from former Mayor Jimmy Griffin. So sandwiches. My personal cartography and the impetus for this talk is much less lofty than any of that, maybe except for the beer cans. You see, and this is sort of embarrassing, but not too embarrassing not to admit to a room full of people I admire, is that I really struggle with estimating distance. As a cartographer, I find that to be a tremendous weakness. So this year, 2018, I decided I was going to work on that. Self-improvement. And not just by like learning the history of the mile, although that was pretty cool. I wanted to develop my own measurement to broaden my knowledge of cartographic scales. Like, if we can have a map with 5 scale bars, if King Henry I can issue a decree that the length of a yard is the distance from the tip of his nose to the tip of his outstretched thumb, which is apparently true, why can't I create something that works for me? We are just 3/4 of the way through the development of the sandwich year, or how far I eat in submarine sandwiches in a given year. I usually tally monthly, but I did make an exception for this conference, so year to date, as of lunch, I am at 453 and 3/4 inches. The methodology for this is not terribly scientific, but like, neither am I. I just carry a measuring tape with me at all times in case I eat a sandwich. And submarine sandwiches are defined as any sandwich that is longer than it is wide, and that does include the sort of, this sort of, I guess, party sub situation. So sub roll, yes. Sliced bread, no. But this, it's not always that easy, whatever is. There's some things that I've avoided eating because I don't know where to draw the line. So this project, it's not terribly visually exciting right now. I actually almost cut this part of the talk just because I don't have like anything to show, but it's part of the process. So what am I going to do with this information come December 31st? I mean, I'm obviously going to map it. I'll put it in the map gallery next year. It's difficult to say what that will look like, though, because as I've been tracking this data, I've realized just how bad my sense of scale is. I kind of thought I was going to have like miles of subs. Today is day 289 of 2018. I'm at sub number 61. So that's, maybe one sandwich every 4 to 5 days. So current projections have the sandwich year ending with approximately 550 inches. It's about 15 yards, or to put it in the terms of something that you have seen very recently, that's 2.5 Putinger maps. The final results from this project will be put up at sandwichyear.org sometime mid-January. Look for it or don't, that's fine. We do have some time for questions. If you have a question, you do have to preface it with telling me an example of your own personal measurement. Please don't look at the dissuaded man.